Welcome to a new In the Mail, the series that will touch both your passion for electronics and your bank account at the same time. We're going to start with this hot glue gun, and this might look familiar, and that's because I got a similar one maybe a year ago, and the one I got back then still works fine. It's just that I used it to dispense some wax sticks for creating wax seals, and so it's pretty hard to clean now, and I've decided to just get a new one for hot glue. It's the same model, it's 120 watts, 11 millimeter sticks, and probably made by the same factory, but it just has a different sticker on it. I was quite happy with this model. It has good power, it heats up fast, and it gives quite a wide range of adjustable temperature, so you can have the hot glue pretty liquid or not. So I can highly recommend this model if you're looking for a hot glue gun. I think you can probably find one with the right socket for your country. I got the US plug style because it was the only one available in stock at the time when I ordered this, but I can easily just swap this with a 2-pin European plug. This video is sponsored by JLCPCB.com, a professional PCB supplier who can offer 24 hours turnaround time for prototype PCBs for just $2. You also have a selection of solder mask colors with no extra cost and affordable laser cut stencils, so it's definitely worth checking them out. Next up, I have some action camera accessories for the GoPro 7. I got one of these floating hand grip handles and a waterproof enclosure. I believe the GoPro 7 already is waterproof rated with the built-in enclosure, but I'm not sure how that will cope with diving or salt water, so I got this enclosure for some extra protection. I also got some of these moisture absorbent pads that you can place inside the enclosure to avoid any condensation forming on the inside. I do not yet have the GoPro, but I plan to buy a GoPro 7 Black for an upcoming trip. It's a good camera, and with its stabilization features should help me capture some nice clear sharp videos. Next up, I have this rather strange looking tube, and this is called a Pitot Tube and is a device used for measuring airspeed, especially on airplanes, but it can be used in other places like boats or cars. I'm not going to go into the theory of how this works, there is plenty of material on the subject, but essentially you have this tube pointing forward, and you can connect the two outlets we see here to a differential pressure sensor with two measuring ports. This is useful because when a plane or any other vehicle is traveling at high speeds, especially important for a plane because when it's flying, the ground speed measured by the GPS can often be misleading depending on the wind the airplane is facing in the sky, which can cause the plane to stall even though you thought you had enough speed. Autopilot systems will constantly measure the true airspeed with this sensor and report back to the pilot or use that data for autopiloting. Next, I have a set of laser printer imaging unit chips. I have this Konica laser printer which I got used for very little money about 3 years ago, and I've been very happy with the unit. It's been printing fine for the past 3 years, but at some point it just asks you to replace the imaging units because they've reached the maximum number of prints they've been designed for, which is typically 30,000 pages. Well, I've reached that limit once and I've replaced the chips with these types of chips that I got from AliExpress, and the printer continued to print just fine, thinking it got a new imaging unit, but all it got was new chips. Now I've ordered a new set of chips to keep them around for the next time the printer thinks it needs new imaging units. Of course, this can't go on forever. Eventually the imaging units will accumulate enough wear that they would cause trouble with printing, but for now it seems to be going strong, so I see no reason to replace them if I can just trick the printer with these cheaper chips. Next, I have a CO2 sensor, and this is model MHZ19B. I've ordered this a few months ago, and if I remember correctly, I did some research before ordering, and I think this is the cheapest sensor you can get that actually measures CO2, because the cheaper sensors just estimate CO2 values. And as you go up in price, you start getting more accurate sensors, but obviously more expensive. This one in particular works with infrared for measuring absorption of light into gas. It's 0 to 5000 ppm measuring range and has a UART or PWM output. The working voltage is 3.6 up to 5.5 volts, but the digital interface level is 3.3 volts, so it's likely using an internal 3.3 volts regulator to power the microcontroller it probably has under this shield. It also has an internal temperature sensor, and it does temperature calibration, and it's supposed to have an accuracy of plus or minus 50 ppm plus 5%, which should be fine for general use case. I got this sensor because I'm curious what kind of CO2 levels do I have in my house, especially at night when the windows might be closed. I plan to hook this up to an ESP32 and collect the data, so maybe I'll do another video on the subject after I design a PCB for this unit. Until then, check out the link for this in the description below the video. I also got a second sensor, or actually there are two sensors on this small board. There is the HDC 1080, which is a digital temperature and humidity sensor, and there is the CCS 811 digital gas sensor, which contains a metal oxide sensor able to sense total equivalent volatile organic compound, and based on that I think it estimates the amount of CO2. The CCS 811 will use the temperature and humidity data from its companion chip to do correction on its own measurements based on current temperature and humidity values. It would certainly be interesting to place this sensor side by side with the more expensive one I showed earlier and compare the values we get from them to see if we can actually use one of the cheaper sensors to measure CO2, but that's a subject for another video. Next, I have the BME 680 from Bosch. This is a 4-in-1 sensor. It can measure temperature, humidity, pressure and gas, although it is not clear to me what kind of measurement it does for gas. They talk about this closed source binary they can offer in the datasheet. It's called Bosch Software Environmental Cluster, which based on the data from these four sensors will output an indoor air quality index with values from 1 up to 500. Same as before, this is a cheaper sensor that does a lot of math and compensation in software to give you that air quality index without actually measuring CO2. I wouldn't be able to compare the air quality index I get from this sensor with the other two I showed so far, because that's not a real measured value, it's just something it computes, and I cannot get the same value from the other sensors. But nonetheless, this has some applicability and might be useful if you base a product around that air quality index number. I also noticed there is a chip from ST on this small module. I don't know what's happening here. Maybe it's a microcontroller and it's running that Bosch library inside, and maybe it just gives us a serial output with that air quality index value. Next up, I have some RFM69CW transceivers, and these are the 433 MHz version, and they're basically an ISM licensed free band transceiver that you can use for data collection, remote control, stuff like that. Hopefully the 433 MHz frequency will mean I can get better range with this than with other modules based on 2.4 GHz or even 868 MHz. At some point a few months ago I wanted to keep a log of the temperatures happening in a car which sits outside. I was curious of how that data would look and what kind of max temperatures would be reached in the hot summer sun, as well as what kind of temperature differentials would be reached between day and night. I tried using some sensors and transceivers I had, which were based on the Spirit 1 modules from ST. They were running on 868 MHz, and I was logging data with a Raspberry Pi which sat remotely in a building 30 meters away. But the signal kept breaking up, so I wasn't getting a reliable connection. As you can imagine, the car shields the signal pretty well. Now the obvious simple solution here would be to log the temperatures locally and download it to a computer, but I thought it would be interesting to also get a live reading, So that's why I ordered these transceivers, thinking that maybe these would do better over the distance. So maybe I'll continue with this project, but sometimes it just takes so long for stuff to arrive that the interest to building that project slowly decreases up to a point where you kind of abandon the project. And I was wondering, does this happen to you as well? Next up, I have a large selection of lenses for LEDs. So the idea here is that you might have your white LED, or doesn't really matter which color, and that LED might have a certain light angle output, let's say it's 60 degrees, and you might find that to be less than perfect for your final application. You might want to build a flashlight that will have a tight spot, and you would then use a collimating lens, or you might want a wider angle, in which case you use a wider angle lens. So let's start with these two that I got here. These are designed for XML Type LEDs, and these are usually higher power and have a square SMD package, hence the square opening at the bottom of the lens. The one on the left is 28 degrees wide, and it has this kind of frosted lens that will diffuse the light. The one on the right is 10 degrees angle, and it's a clear lens. So this means it will concentrate the light in a spot and shine further away. And I'll try to include some pictures later during editing to show you the different lenses and how they look when they project light. Next up, I have some smaller lenses, and these are designed to go over surface mount 1 watt LEDs, the type that has the two connections going sideways. I think they're supposed to be glued to a PCB or maybe somehow secured mechanically, but you can find these in a wide variety of options. I have just two here, 15 degrees and 30 degrees, and same as before, I will include an image overlay with some light projected from these lenses so you can get a feel of the difference between the two angles. And this is the third type of lens I got. It's a larger assembly, and it's intended for the same 1 up to 3 watts LEDs with sideways connections. It has this black shroud, which could probably be useful if you don't want any light leaking sideways. And same as before, you can order these with different angle specs, and the ones I have here are actually 15 degrees. And this is how one of these looks like with an LED that's shining through it. Next up, I have a few different heatsinks in here which were ordered with the intent of cooling LEDs. These two are 150 by 20 by 6 millimeters thick, and these, let's check the weight, they're about 22 grams each. They are fairly inexpensive and could probably keep cool a bunch of small LEDs. The second type of heatsink is 100 by 25 by 10 millimeters, and this one is about 31 grams in weight, so a bit more weight into this one. The fins are also a bit longer, and the third option I have here is just a copper strip. This is 3 millimeter thickness, 15 millimeter wide, and 250 millimeters long. It's supposed to be 99.6% purity copper, and the weight, let's check it on the scale, is about 100 grams. And you can probably cut this to the required size and use as a heat sink on the back of a PCB, or maybe just as a high current bus bar by drilling and socketing this to a high current circuit. And the last item in today's mailbag is this CP2104 based USB to serial adapter module. I have the older CP2103 chip, I have the CP2102, so I also had to order their brother, the CP2104, or their sister, I'm not sure, but to have the complete family. This breakout board has a solder jumper on the back for selecting 3.3 volt or 5 volt option, and the internal regulator of the CP2104 can output up to 100 milliamps on the 3.3 volt rail. I'm not a fan of using the internal regulator from USB to serial chips, but if you're designing a circuit where you only have a couple of chips with low power consumption, you can power them from the USB to serial chips and save your BOM cost by not having to use another regulator. And I must say that the one inside the CP2104, which can output up to 100 milliamps, is not bad at all, because I believe all the others I've seen before can only output a maximum of 30 or 50 milliamps. So this one is double that. That was all for today. I would really appreciate your support on Patreon, or even just hitting the like button on this page. That also helps. Let me know your thoughts in the comments below. Did you find something interesting to order in this mailbag? Thank you for watching, and I'll see you next week with a new video.